Welcome back to the STEMverse Academy. If you've been following our series on integrals, you've already seen how integration works and learned the basic rules. But what happens when the function inside the integral is complicated? That's when you pull out one of calculus's most powerful tools, U-Substitution, the reverse of the chain rule. It might sound intimidating, but by the end of this video, you'll see it's just a clever way to simplify what looks complicated. In derivatives, the chain rule helps you take the derivative of a composition of functions. In integrals, U-substitution is how we reverse that process. It helps us simplify complicated-looking integrals by changing variables. The goal? Turn a messy integral into one you already know how to solve. Let's take a look at this integral. So, to solve this integral, at first it looks really complicated, but it's not that hard when you use U-sub. So the first thing we're going to do is choose our U value. So here we're going to pick x squared as our U value. And that's because, as we can see, x squared is inside of cosine function. So we always try picking U. Our function that's going to be U is going to be the function inside of a different function. So here the x squared is inside of cosine. So that's going to be our U. And then we're going to take the derivative of that. So d of U equals 2x d of x. So now that we've taken the derivative, we're going to plug in our U in this integral. So anywhere we see x squared, instead of writing x squared, we're going to write U. So here the integral is now going to become the integral of 2x cosine of U d of x. And because we did that, we have to change d of x to d of U over 2x. Because here our d of x equals d of U over 2x. So d of x is now du over 2x. So now we're going to continue solving this. Now we see that our 2x cancels out with another 2x, so we're left with, this cancels out, so we're left with cosine of U d of U. So now we just have to take the integral of cosine of U. So to do that, we just, what makes cosine? What's derivative makes cosine? Sine makes cosine. So the integral of cosine of U is sine of U. And don't forget your plus c. Now it's very important not to forget this step. This is where a lot of people just think they're done and make that mistake. But you got to make sure to change U back in terms of x. So it won't be sine of U plus c, it'll be sine of x squared plus c. Because we have to change U back in terms of x, because we want our answer in x, not in U. So that's U substitution. Now I'm going to give you the steps for U substitution to help you out. So the first thing you do when you have U sub is you choose your U value, so what you want the U function to be. And then you're going to differentiate U, take the derivative of it, and then you're going to substitute everything in terms of U in your function, and then integrate, and then substitute U back in terms of x. That's very important. So it's all about choosing the right u, usually the inner function of a chain, and making sure the rest of the expression fits with its derivative. So to help you pick your u value, this is what my Calculus 1 prof taught me. She told me that you pick it in terms of Lyot. So L is for log, I is for inverse, A is for algebraic, T is for trig, and E is for exponential. So if you have a log function and you have an algebraic function, you're going to pick the log function as your u because it's first. So whatever letter is first in Lyot, that's going to be your u sub over the other one. So if you had a algebraic and an exponential, you would pick the algebraic as your u sub, not the exponential, because A is before E in Lyot. And that's how you're going to pick your u sub and make sure you pick the right one. Now, we're going to try solving another u sub problem. This one's also pretty easy. It's not too hard. So, here we go. We have to pick our u value, so we're going to use Lyot. So, we have a function inside of a function right here. As we can see, this x squared is inside of e to the x. It's in the exponential function. So we have an exponential function here. We have an algebraic function. We have another one here. But this one right here is inside of the exponential function. So that's our inner function that we want to use as u. So u is going to be x squared. And then we're going to differentiate that. So we're going to get d of u equals 2x d of x. And then we have to put it in terms of d of x. So d of x equals d of u over 2x. Now we're just going to rewrite our integral with our new u sub. So everything that's x squared is going to become u. So it's going to be x times e to the u. And then instead of d of x, we're going to write du over 2x. So now this simplifies it a lot. So our new integral, the x here is going to cancel out with this one. So it's going to be e to the u d of u over 2. Now something really cool that we can do is we can pull out that 2. So we can pull out 1/2 and make it e to the u d of u. And as we know, e to the x or e to the u is just e to the u. So integrating that, it stays the same, just like when you take the derivative of e to the x, it's just e to the x. So this is just going to be 1/2 e to the u, but don't forget plus c. And now all we have left to do is turn that u back into terms of x. So it's going to be 1/2 e to the x squared plus c. And that is going to be our answer. Now we're going to try another quick example right here, just to make sure you guys got it. So here our u is going to be the inner function, which is right here. These are both algebraic, so it is hard to tell sometimes. But as we can see right here, this is the inner function. This is being divided by this, so that's the inner function. So we're going to do u equals x to the 3 plus 1. So then it'll be the differentiating of that. So it'll be d of u equals 3x squared. And 1 disappears because it's a constant. Let me rewrite that here. So it'll be 3x squared d of x. And then in terms of d of x, it'll be d of u over 3x squared. So now we're going to plug that into our function here, our integral. And we're going to get So we're going to get 3x squared over u. And then instead of d of x, we're going to do d of u over 3x squared. So here we can see our 3x squared cancels out. So it'll just be the integral of d of u over u. And now to solve this, we're going to do the same thing we've been doing. So we can bring that u to the numerator, or we can just do, as we learned in I believe it was the second episode, we learned about basic rules of integration. So this is going to be ln of u and then plus c. So now it's very important that we change u in terms of x again. So it'll be ln of x cubed plus 1 and then plus c. And that's going to be the answer for this one. So some quick tips for you guys. If you can't rewrite everything in terms of u and d of u, then your substitution is probably wrong. So you're going to want to try a different u-sub. And always simplify first if it's possible, because it can make the substitution obvious and it can really help. So some integrals require a bit of algebra, factoring, expanding, before the substitution will work. Now, if you want to test your u-sub skills, grab the free episode worksheet linked in the description and try out some practice problems. The answers are also in that document. And thank you for learning with the STEMverse Academy. If this helped you, hit the like, subscribe, and turn on notifications for the next episode, where we'll explore definite integrals with U-Substitution. Have a great day.